Hey everybody, this is Craig from Vitex, and today we're talking with data center and telecom providers and answering some of our customer questions. So today we're going to dive right in and talk about a customer question on a feature that we got.
So today we received a question from Tony, who works in a data center, and he wants to know about FEC, or forward error correction, and how it's important in optical networking.
That's a great question, and sometimes I ask myself, hey, what the FEC? What is FEC about? What's all the benefits that we get from it? And why do so many people talk about it? So let's just dive right into that, and we're gonna go ahead and shine some light on it about the what's, the whys, the hows, what are the benefits and the pros and cons of it. So FEC stands for forward error correction. And what does this really mean? What does it give us? So the whole point of FEC, why we want it, is we want to improve our bit error rate, right? Having these really great high-speed networks is awesome, and as our data rate increases, it gives us a lot of benefit. But if all of those high-speed bits come in all wrong, then we don't really get anything out of it. So how do we do this? So what we do is we actually add bits into our payload so that this will actually reduce or take away errors. So I know this sounds a little counterintuitive to add something and it helps us take it away, but we'll get into a little more details of where that is once we understand where FEC is actually working. So when we look at our 7 layers, FEC resides in our physical layer. So this is something that's done in the DSP of either the transceiver or the network equipment. So there's additional processing that goes on there to actually check against these additional bits, check against their parity. And so it makes a decision of, was this correct? Was it not correct? And what do we have to do to make it more correct? And so the whole goal of this is that having these additional bytes, it takes away retransmissions. So that's a huge benefit of what's going on in here, is that retransmissions can get reduced or they can go away in some of the conditions. It also allows us to increase our range. So without having to design new optics that may cost a bunch of money, we can have these FEC algorithms actually increase our range. So we can get sometimes 10, 20, 30, maybe even 40% in some conditions on our range, which is really super awesome. And so another awesome benefit we see is reduction of power. You just heard me mention about, well, we don't need these high power lasers or to transmit with higher power. So that actually reduces our power consumption. So that's another cool benefit. So there's many things that we can add onto our pros that are like really cool, right? And so we kind of like stacked right now that, hey, of course, why wouldn't you want this? So let's just talk about some of the cons. What are some of the trade-offs? So the first one, and a big one, which a lot of people talk about, is the latency, right? So we can see on here where we're adding these additional bits, right, to help us with our parity. And we talked about the payload side is increasing. So that means our data is actually taking longer to get there, right? So it's getting there slower. So our latency is increasing, which we don't really like. We want to have everything in lots of our applications as low as possible. So that's one trade-off. So there's a little negative for us. And then also there is some additional complexity in this. Adding these algorithms in the DSP, somewhere in the physical layer, depending on what component they're going into, it will add some complexity. There's also some network complexity and planning that has to be considered, especially if you're working across different OEMs, third parties, interoperability. You want to make sure if you're doing things in a host or a transceiver that they understand how they're working together. Because if you have component A that supports FEC and component B that doesn't, they're not going to talk to each other. Your system's not going to work. So that's another thing to keep in mind, right? But the benefits really outweigh the negatives in this situation. So let's think about, if we have a signal, what does this really look like? So we're starting off with a basic data signal, and we send it through, our network, our pipe. So as it goes through here, there might be some type of interference. This could be either just because signal to noise ratio is bad. It could be something with the modulation. So we can see times where, we're going to come out really sad because we're going to introduce errors in here where things aren't going to match up, right? But one of the great advantages to bring back that smile on everybody's face is when we're using forward error correction, we can use decisions to make these correct. But what are decisions and how do they actually work? So just to get into this in a little detail, and if anybody has a question, keep sending them in, and we can go through this maybe in another video in a little more detail. We really have two types of decisions. We have a hard decision, which involves our bits, right? Our block codes. We have a soft decision, which is more about like our convolution codes. So depending on what we're doing, the network can use different decision types to see how best to support FEC. And so just to give you kind of a little bit more info on what transceivers, what hosts do this, you know, you can give us a call here at our New Jersey location. We can talk to you about all of our transceiver products. But just so you know where FEC is not, right? FEC's not in these cables, right? So I don't know what everybody's talking about. If they say that's where it is, it's not there. So when we look across some of the transceivers, we can see 25 gig, you know, RS FEC is needed to help us get those additional bit error rates and lengths that we were talking about. Also in 100 gig, we see it in NRZ as well as PAM4. But, you know, one gotcha there to remember is in the NRZ platforms when we're using like a LAN WDM, it's not really needed. And we can definitely talk about that more detail if you're interested. And then when we move on to higher rates like 400 gig, it kind of moves out of the transceiver. And then this is when our hosts get involved. So our hosts have to be able to support FEC as well. And especially, it's super important on our software side to read what kind of transceivers we have, what kind of FEC we're using, so we can see if the host needs to enable it or disable it. So there's a lot of little gotchas in operability. And if you have any questions about that, we're here at our New Jersey location to totally help you out. Call us, we'll work with you through your solution. So hopefully you have a better understanding of FEC. And until the next question comes in, remember to keep sending them because you can be one of these lucky people who gets free coffee from me. I'll see you next time.